Okay, so this was a homework question, and somebody asked for some explanation. So this is find the surface area of a circle rotated about a line that is touching the circle. And so let's draw ourselves a little sketch like that. Something like that. Okay. So we have x squared plus y squared equals r squared, or y is r squared minus x squared. Take the square root of that. And so we really don't need the lower half. Okay, so there we've erased the bottom half because it's not necessary. And then rotated about the line y equals r. So that will be right there. Okay, and so here's the line y equals r. And so what we want to do, if we're rotating about this line, then it must be little dx slices, and it must be going from here, which is minus r, to here, which is r. So x equals minus r to x equals r. So your integral is going to go minus r to r, and it's going to be a dx integral. And so which one? Is it area is pi r squared, or circumference is 2 pi r? What's going on? Right, so it's actually, you're building little tiny cylinders, but you have to think about exactly where the cylinders are going to go. So you're going to actually be flipping around this axis. So you're going to be getting little cylinders like this. Okay, but you need to find this distance, the distance between here and here, or between here and here. Okay, so it's going to be somewhere in this expression. You're going to get r minus this expression, r squared minus x squared. This right here is this green distance. Okay, so we know that's going to show up somewhere in our formula. And so let's see, we have let me just go look. I'm going to find the page number in the book so you know exactly where the formula is. Okay, so we have to adjust a formula that's in the book, but you want to refer to page 547, and I'm going to erase that because I don't want it to stay on the screen too long. That's the page you're looking for, and you're looking for the formula that looks like this. And it's about the x-axis, and we have to adjust, this is b to a, 2 pi f of x, and then this lovely expression, and dx. This is the formula that we're using, but we're going to adjust it. And what's normally f of x is now this expression, because in that formula we're flipping things around the x-axis, and the x-axis is y equals 0. So when you're flipping about y equals 0, which is the x-axis, this is the formula you're going to use. But we're not. We're flipping about y equals r, which is parallel to the x-axis, so it's very, very similar. So let's put all the pieces back in. We're going to need a 2 pi. That part we need. We've got the green part, and we need this lovely magical piece here that we haven't yet calculated. So let's go ahead and calculate that piece and then make some space for it. Okay, so this pink piece, we need f prime, or y prime, is what? I don't know. Well, y is this expression written to the 1/2, so y prime is 1/2 of the same expression to the minus 1/2 times the derivative of what's inside. And so then we're going to cross off the 2's because they're extra now, which is minus x over the square root of this mess. Okay, so then we need, so this is a lot of writing. I'm just going to get rid of this so that I have more room to write. This is just going to be kind of developing here on the screen. If I'm going to square this mess, I'm going to get x squared on top and r squared minus x squared. That's good. Okay, so that's good. I don't feel bad about erasing because you guys can back up the video. Okay, now 1 plus y prime squared, and then under the square root. So we have to add 1 to this. Okay, so to add 1, I can add 1. What's 1? It's r squared minus x squared over r squared minus x squared. Great. Then our x squareds go away, and this whole thing has to go under the square root. So we have r squared over r squared minus x squared. So we're going to get r in the top and the square root of r squared minus x squared on the bottom, which looks horribly, horribly disgusting. So let's put it in here. Ah, how did I get that? Okay, so I need to put r over this mess, and then we've assembled our integral. Okay, so I don't really know what to do next, so I'm going to just continue and hope I end up in a place that looks familiar. One thing I can do is I could use the fact that this is symmetric to make this 4 pi on the outside and let myself go from 0 to r instead of negative r to r, but that's not necessary. I can just see what happens. I'm going to multiply these guys together, and I'm going to get myself 2 different integrals, because I suspect that these guys are going to be somewhat different to solve. I'm going to get r squared over r squared minus x squared, okay, dx, and then I'm going to get minus of the other one, and then I'm going to get r squared over x squared. These guys are going to cancel out, and it's just going to be r. So yes, they're going to be dramatically different. Can you see where those came from? Let's see if I can circle the pieces. So this r, not a good color. Let's try yellow. This piece and this piece came together to give me that. All right, so that's where that came from. And then the second integral came from this guy and this guy combining. So I have the minus sign from here ended up down there, and then these guys cancel out, and I'm left with just r. So hopefully that's right, and that means that this whole piece is really, really easy, right? Because it's just going to be r times x as x goes from r minus r, so it's just going to be r squared minus a negative r squared. That's going to be a mess, right? Let's see. Let me just do this out. So this piece is going to, I'm going to keep the minus there, and then 2 pi times, so r times x, r to minus r. So it's going to be r squared minus a negative r squared, so 2r squared. So there's just going to be a 2r squared there. So this 2 turns into a 4. Okay, so that's pretty straightforward. Now what about this mess? This is the mess I'm worried about. Right here, that's the mess. Okay, so I'm pretty sure that's going to be something I'm going to look up. And I know, first of all, the r squared is going to come out here because it's not really part of the problem. The problem is this expression, and I suspect we might be able to do it with trig substitution, but I'm just going to look it up on a table. So I'm going to pause while I go get that for you. Okay, so we have it. It's the following. It is reference page number 6, formula number 16. All right, so formula 16. And that is angle whose sine is x over r. So the formula uses a u instead of an x and an a instead of an r. So you just have to take and swap out every u is an x and every a is an r, and you don't need to do the plus c because it is a definite integral. Okay, so then we just do the following. We say arc sine 1 minus arc sine of -1. Okay, and we should realize we could have just made this 0 and doubled that. So we're really expecting to get 2 copies of the same answer. So let's see what's going on. Angle whose sine is 1. Let's remember what it looks like to be arc sine. Here's what sine of theta looks like. So when sine is 1, we're at pi over 2. When sine is -1, we're at negative pi over 2. So this is going to be pi over 2 minus negative pi over 2. So sure enough, we got 2 of the same thing. All right, so this is going to be, let's see, we're going to get a single pi here. So pi times pi is pi squared. And this is, let me pause this for a second again. The answer in the back of the book says 4 pi squared r squared, so clearly I made a mistake. I'm going to pause while I look for my errors. Okay, so if you see this video, it's because my answer's right, but you may never see this video. So what I have right now is this discrepancy. Is I have my answer, and here's the book answer, and I've checked and I have not yet found an error. And let me just review again. So this part here is the part that gives you is from the arc length formula. Sorry, I didn't mean that. This part is from the arc length. Okay, and then the part that's 2 pi r is here, that's giving you your cylinders. And so it seems fine to me. Not sure what else I can do, and I double checked all the steps, and the thing that bothers me is that I really have to do this r minus this function, and that fundamentally splits this up into 2 pieces. There's a part that has an r squared in it, and that part ends up with a pi because of this arc sine business. But the other piece I get, this piece, is going to cancel with that, okay? And this is the part that's a mystery to me, because I don't understand how the book can get an additional pi out of this. We've got this r comes out, all right? And so you're going to end up with an r squared here, but there's no way to get a pi out of that piece, and there's no way to get rid of that piece. So fundamentally, I don't know how the book is ending up with this. It makes no sense to me. So if you see this video, it's because I check over my work again and again, and I'm pretty convinced that the book is wrong, and or else you'll never see the video. Okay? So sorry. Oops, sorry, I hit pause instead of stop.